Good morning, students. I am Vinayak from channel Physics Adda. Today we will be solving 5 questions which have been asked in previous NEET exams. Okay, so let us start the questions. Question number 1. This question was asked in NEET 2017. Okay, so if you read the question carefully, you can pause the video and try to solve the question. Okay, now let me solve the question. Here we are having two blocks. First block is block A, second one is block B. The mass of block A is 3m, the mass of block B is m. So these two blocks are tied with a massless and inextensible string. It means that the mass of string is 0 and the string is inextensible. Okay. The whole system that is system consisting of mass A and mass B together is suspended by a massless spring as shown in the figure. You can see the spring over here. The spring is massless and mass of spring will be what? 0. Now we need to find the magnitude of acceleration of A and B immediately after cutting the string. Okay. So what will happen if we cut the string? Now, let's analyze the situation like this. I'm having two masses, 3m and m, suspended with a massless chain, a massless spring. So the mass of the total system will be 4m, 3m plus 3m plus 4m, 3m plus m is 4m. The net force acting downwards due to gravity will be 4mg, and spring force will be acting away from the block like this, away from the block. So it will be FSP. Okay, this situation is at equilibrium. Equilibrium. What is the meaning of equilibrium? The net force acting on the system is 0. That is the equilibrium position. Okay, so initially the blocks are at equilibrium, right? So in case of equilibrium, the spring force becomes 4 mg. Now let's analyze the second situation when a massless string is cut. I'm cutting the string like this. Now before cutting the string, there will be some tension in the string. So this tension will be T, which will be acting away from the block in this direction, and here there will be also tension which will be acting away from block A. So the magnitude of tension will be same since the string is same. String connecting the block A and block B is same. So here if I am cutting the string, this tension will be 0 after cutting, right? So if I am drawing the free body diagram of individual blocks, first block B of mass m, then the force due to gravity will be mg. If I am cutting the string, then the tension force will be 0. So again there will be free fall of the body, free fall, free fall due to gravity. So this body will move downward, block B will move downward. So what will be the acceleration to gravity of block B? It will be the acceleration of free fall. What is the acceleration of free fall? It's g in downwards direction, right? Now consider the second case of block A. So in block A, this block A will also try to attain the equilibrium. If this tension T becomes 0, this if this tension T becomes 0, equilibrium gets disturbed, and again body will try to attain the new equilibrium position, right? But before attaining the new equilibrium position, there will be a motion. There will be a motion of block 3m. So this motion, if my observer is standing over here and if he is watching the whole process from here, from here, from point O, then he will find that this mass M is falling downwards. There will be a free fall of mass M, okay, or block B, and this block A will be going upward, right? So relative to point O, this block A will be moving upward with some acceleration A. I need to find this acceleration. That is the question. So if mass is 3m, then force due to gravity will be 3mg acting downwards, and spring force will be acting upwards, right? And since the relative motion will be in upward direction, like this, with acceleration A, A. So mass of block A into acceleration of A is equal to what? The force acting in the direction of acceleration or in the direction of motion, that I need to take it as positive. FSP will be positive, minus the force acting opposite to the direction of motion will be negative. So it will be 3 mg. What is the value of FSP? We have obtained from initial equilibrium, it's 4 mg. So I'll put it here, 4 mg minus 3 mg. So this becomes mg. So MA into AA. What is MA? Mass of block A is 3m. So this 3m is equal to 3ma is equal to 3m into acceleration of A is equal to mg. Okay. So A acceleration of block A will be what? G by 3, which will be acting upward. Okay. So the answer is what? Answer is this one, G by 3 and G. This is the right answer. Question number 1, answer is option A, G by 3 and G. Okay. Now let's move to the next question. Question number 2. Question number 2 says that you can pause the video and try to attempt the question. Okay, I'll solve the problem. Okay. I'm having a table and there is a peg on the table and a string of length L is attached to the peg, and at the other end there is a particle of mass M. So here is a particle of mass M. Okay. So I need to find if particle moves with velocity v, if this particle moves with velocity v, I need to find the net force on the particle directed towards the center. Directed toward the center means toward the center, what will be the net force? So since this mass M is tied to the fixed end with some string having a length L, so it will perform circular motion along a curvature, right? It will perform circular motion. So if it is performing circular motion, in that case, what is the net force on the particle directed towards center in circular motion? That is centripetal force. Centripetal force. Okay. So what is the value of centripetal force? This is the net force directed towards center. Towards center. Okay. So this will be what? Force acting in this direction, T minus 0. Is there any force in this direction? No. External force in this direction? No. Right? So this will be what? T. So the answer is T. Tension. T is tension due to tension in the string. T represents tension in the string. Okay. So option number D is the right answer for question number 2. Now let's attempt question number 3. You can read the question and try to attempt the question. You need to know the concept of momentum and impulse if you want to attempt this question. This question was asked in NEET 2016. Okay, a rigid ball. We are having a rigid ball like this. We are having a rigid ball like this. This is the rigid ball, and this ball moves in this direction. It makes angle 60° with wall. Makes angle 60° with wall, and it gets reflected with the same angle without loss of speed. There will not be any loss of speed. This speed is v. This speed after reflection will be v. Okay, before reflection speed b, after reflection speed will be v, since there is no loss or no loss of speed. Okay, so if I am resolving this v, that is initial v, in two components, it will be like this. Since this angle is 60°, this angle will be 60°. So this will be what? V cos theta. This component will be V sin theta. If this is 60°, then this component towards or downwards will be what? This component will be V cos theta, and this component will be V sin theta. Since this angle is 60°, this angle will be 60°. Okay. Now, next thing is that I need to write the momentum in vector form. Okay. What is change in momentum? I need to find. What is change in momentum? Because change in momentum will be what? Impulse imparted by ball. Impulse imparted by ball on the ball. Okay. Change in momentum of ball will be impulse imparted by ball on the ball. Okay. So I need to find this one. So I will be writing it like this: x component, y component, p initial and p final. Because this change in momentum will be what? P final minus p initial. Okay, what will be p initial? Or p final I will first write, then I will write p initial. What is p final? This one. So this is, I will be assuming coordinate system like this. Here there will be positive, positive, here will be negative, negative. All the vectors along OX will be positive, along OY will be negative, along OY dash will be negative, and along OX dash will be negative, or X prime will be negative. Okay? So P final will be V, X component will be V sin theta, MV sin theta I cap. So this is minus, this will be minus MV cos theta j cap. So this I and j will be unit vector along x and y respectively. Okay. So this will be minus mv. This is the initial. This is mv acting downwards. So along oy dash. So it will be negative. M minus m into v sine theta I cap. And this will be minus mv. This will be again acting downwards. This will be acting downwards, and this minus mv sine theta will be what? It will be positive. This will be positive. This is acting in OX direction, so this will be positive. This is minus mv cos theta j cap. This will be negative. I need to do PF minus PI, so this will be minus into plus becomes minus. So this is minus twice mv sine theta I cap. This minus minus becomes plus, minus minus becomes plus, so minus plus becomes 0, so this will be 0. Now, what is the value of sine 30 degree? It will be 1 by 2, right? So, this change in momentum will be minus twice mv into 1 by 2 I cap. So this will be minus mv I cap. So, what is the magnitude mv? What is the magnitude of change in momentum? mv. So here this mv will be nothing but change in momentum, which is equal to impulse imparted by ball on the ball. So the answer is mv. So right answer is option A to question number 3. Next question is question 4. Now this is very interesting question. So what concepts you need to understand if you want to solve this problem? The first concept is friction. The second concept is banking of roads. Banking of roads. Okay. So here, if you see, the car is negotiating a curved road of radius r. I am having a curved road like this, which is having a radius r. Okay, and car is over here. Car is over here. What is the centrifugal force if my observer is sitting in the car? Okay, and then centrifugal force. What is centrifugal force? It is the pseudo force. It is the pseudo force which will act in this direction. It is mv square by r. Okay. Now the second thing which is given is that the road is banked at an angle theta. This road is not flat, it is banked. Okay, so this road is banked at angle theta. So if this is my car, if I'm taking, this is the top view, this is the top view of the car. And if I'm taking side view, or I'm taking front view of the car, front view, it will be like this. Okay, what are the forces acting? So here force mg will act downward, and second force will be what? Normal reaction n, which will act perpendicular to the inclined surface n, and road is not smooth. Okay, there is friction between tire of the car and the road, which is mu, where the coefficient of friction is mu s. Mu s. I have been asked the maximum safe velocity on the road is. There are two things. First is that maximum. There are two words. The first word is maximum and the second one is safe. Safe. What is the meaning of safe? It means that there should not be skidding. There should not be skidding of the vehicle. Okay. And what is the meaning of maximum? Here the friction is maximum. It means that the friction is maximum, or it has limiting value. Okay. What is the limiting value of friction? Mu s into n, right? So it will act in this direction. Why? Because skidding will happen like this, in this direction. Okay. Let's analyze the situation like this. This is the vehicle, okay, and this is the banked road. This is what? Banked road. Okay. This is the banked road. There is some angle of banking, okay, with respect to horizontal. So this vehicle is moving. So what are the forces acting on the vehicle? The first force is what? Force due to gravity, which will be acting downwards, mg. Second force is centrifugal force, which will be mv square by r. Now there will be a normal reaction perpendicular to the surface. Okay, so this will be what? It will be like this, perpendicular to the surface. Okay, this will be like this, and there will be a frictional force. There will be a frictional force F. So this frictional force will be along the plane of inclination. Okay, acting inwards. Acting inwards, since motion of skidding will be outwards. Skidding will be outward. And if observer is sitting in the bus, okay, so you'll find that skidding is outward. Then he will then frictional force is the what is friction? Friction has direction opposite to the relative motion, or it opposes the relative motion or tendency of relative motion. Okay, it very important word is opposes. It opposes the tendency of relative motion. So relative motion means here is skidding, which will be in outward direction. Okay, so friction will act inward. So if I am drawing FBD, free body diagram, okay, free body diagram for this problem, then it will go like this. It will go like this. Here I am having a plane of inclination or inclined plane at an angle theta. This is my vehicle. Okay, what are the forces acting on it? The first force is normal reaction. This will be acting away from the block or perpendicular to the surface. There is a centrifugal force mv square by r. Okay, then we are having mg or force due to gravity. It will be having two components. The first component will be what? So, and the other force is F, friction. So it will be like this, frictional force will be. So if you can see the figure, if this angle is theta, okay, so what will be this angle? What will be this angle? This angle will be also theta, so it means that if this is theta, this angle will be theta. Okay, so this component will be what? N cos theta, adjacent component, and this component will be what? This will be N sin theta. Now, in similar way, if you consider the friction, friction makes angle theta with horizontal, right? Because it is along the inclined plane, and plane makes angle theta with horizontal, right? So what will be the component of friction in this direction? It will be F, it will be F cos theta, right? Because this angle is theta. So this will be F cos theta, and here it will be F sin theta. So I will draw it like this. This is M, Here I am having mg. Okay, here I am having mv square by r. Here I'll be having n cos theta. Then again I'll be having n sin theta. I'll be having f cos theta, and here I'll be having f sin theta. Okay. Now this is in equilibrium, since we have converted accelerated or non-inertial frame of reference to inertial frame of reference. We have considered the centrifugal force, which is a pseudo force, right? So if I am taking the force balance, it will be n cos theta is equal to mg plus f sin theta. So n cos theta minus f sin theta is equal to mg. This is equation number 1. I am taking what? Vertical equilibrium. Vertical equilibrium. If I am taking horizontal equilibrium, in this direction, it will be mv square by r is equal to this force n sin theta plus this one cos theta. Now you have two equations. I need to find what? I need to find v. There are two words which are given in the problem. Now you see like this. These are the two components of normal reaction and friction, which are balancing centrifugal force mv square by r. This force is responsible for skidding. Okay, so this vehicle will be thrown away. Vehicle will be thrown away. Okay, thrown away from here. And these two components, the first one is what? This one is, the two components are F, which are the two components? F cos theta and N sin theta. These two components are responsible to balance the outward force, centrifugal force. Okay, so they will stop the skidding. So there are two important points to be noted. Point number 1 is that which are the two forces which are responsible to avert the condition of skidding? It is n sin theta and f cos theta, the combined effect of normal reaction and f friction. Normal reaction, and second is friction. So both are what? Both are contact forces. And this is first, and the second thing is that both are inclined. It means that there is some inclination with respect to horizontal. Okay, that also play major role in avoiding skidding. Okay, so if you see the problem again, the two words are given. The first word is what? The first word is maximum, and the second one is safe. Okay, so here what is the maximum value of f? It will be f max. Friction max is equal to f limiting. It is mu times n, mu times normal reaction. So I'll putting it over here and over here. I'll be getting two equations again. Equation number one is n cos theta minus mu n sin theta. Equation number one becomes is equal to mg. Second one is mv square by r is equal to n sin theta plus mu n cos theta. Here mu is mu s, static friction. Okay. This is equation 1, equation 2 rearranged after putting f is equal to mu n. Now if you see the equation, I'll divide equation 2 with equation 1. What I'll be getting? I'll be getting mv square by r divided by mg is equal to gets cancelled. I will be getting v square by rg is equal to n sin theta plus mu s n cos theta, and sin theta plus mu s n cos theta divided by this one, this side, n cos theta minus mu s into n sin theta. Okay, so I'll take n common, n common. This n divided by n gets cancelled, so this is n by n getting cancelled. The remaining part will be sin theta plus mu s cos theta and cos theta minus mu s sin theta. This is v square by rg here. If I am dividing both numerator and denominator by cos theta, what I'll be getting? I'll be getting v square by rg is equal to, yes, sin theta divided by cos theta is what? Tan theta plus this is mu s cos theta divided by cos theta, means cos theta gets cancelled, cos theta gets cancelled, and I'll be only remaining with mu s. Here cos theta gets cancelled, which is 1 minus this mu s sin theta by cos theta. Sin theta by cos theta is tan theta minus mu s tan theta. So b becomes what? B becomes, I will take this rg on this side, mu s plus tan theta divided by 1 minus mu s into tan theta under root. This is the answer. This I have been asked, what is the maximum safe velocity? Okay. So rg mu s tan theta plus divided by 1 minus mu s tan theta. Okay. So rg mu s tan theta, mu s plus tan theta upon 1 minus mu s tan theta. Okay. So the right answer to question number 4 is D. Right. Now let's move to the next question. This question requires the knowledge of friction. There are two types of frictions, as we know. Now you can pause the problem, read the problem, and then try to solve the problem. Okay, I will solve it. The first friction is static friction, the second one is kinetic friction. Okay. The problem is the plank, this is the plank, this is the plank, with a box on it at one end is gradually raised. So this plank is gradually raised about the other end As the angle of inclination with horizontal reaches 30 degree, so this is the plank. Okay, I'm gradually raising this plank like this. Okay, when this angle becomes 30 degree, this block at one end, the box starts to slip and slides 4 meters down the plank in 4 seconds. Okay, then coefficient of static and kinetic friction between box and plank. I need to find the value of mu s and mu k. Okay, respectively. So here are the four options, and this question was asked in NEET 2015. Now, as we know, static friction means what? It is self-adjusting. It is self-adjusting friction. Means it is not constant. It is variable. While this kinetic friction is constant, what is the value of kinetic friction? Coefficient of friction K into normal reaction. And this one is what? It varies. It is variable. It varies from 0 to F limiting. Okay. This is the range. It will try to adjust itself such that it opposes, the static friction opposes the tendency of relative motion. Means there will be no relative motion, but there will be tendency of relative motion, which static friction will oppose with self-adjusting value between 0 to F limiting. This is the meaning of static friction. Okay. So here will be solved. If we want to solve this problem, in case of static friction, since there will be no relative motion, there will be only tendency of relative motion. What will be the acceleration on the box? In that case, it will be 0, whereas this will be non-zero. It will be non-zero over here, right? It means that this will be in equilibrium. So if I am considering the case of static friction, what are the forces acting? What are the forces acting? The first force is force due to gravity mg. So this component will be what? This component will be, since this angle is theta, this angle will be theta. So this will be mg cos theta, and this component will be mg sin theta. Okay, if my observer is standing over here and he is watching the process from point O. Okay, so you will find that this block is having tendency to move in this direction, downwards. Okay, that is not moving because static friction is opposing the tendency of motion. So static friction will act in this direction. Okay, this is which is self-adjusting. When this angle becomes 30 degrees, the box is about to move. The box starts slipping. The box is about to slip. So in that case, it will be F limiting, right? So if I am taking, and this will be what? Normal reaction, which will act perpendicular to the inclined plane, perpendicular to the inclined plane, right? So this I can write like this. If I am taking vertical equilibrium along inclined plane, it will be n is equal to mg cos theta. Now I am taking horizontal equilibrium along inclined plane. Okay, along inclined plane, it will be this mg sin theta is equal to what? F limiting, which is having a maximum value of mu times s into n. I'll be getting n from here, so it will be mg Sine theta is equal to mg cos theta. Mg cos theta means n into mu s. Mg gets cancelled. Sine theta by cos theta is tan theta. So mu s is what? Mu s is equal to tan theta. What is the value of tan 30 degree? Theta is 30 degree. It is what? 1 by root 3. There is a trick to keep in mind the values of standard angle. 30 degree standard angle. Okay. If I am having, you have to only remember the value of sine 30, which is half. What is sine? Sine is this side, this is 30 degree, this side divided by hypotenuse. Okay. So this is 1 and this is 2. This will be what? Root 3 as per Pythagoras theorem. 4 minus 1 is 3 under root 3. So what will be the cos of 30? It will be adjacent, this one divided by hypotenuse. So this will be root 3 by 2. Right? And what will be tan 30? This will be 1 by root 2, 1 by root 3. So here it will be 1 by root 3, which is nothing but 0 0.6. Okay, 0.6. Now we have found coefficient of static friction. Okay, mu s. So its value is 0.6. So option number A, C or D. These are the two options with values as 0.6, 0.6. Now I need to find. So this is not valid. Option A, option B. Now I need to find coefficient of kinetic friction. Okay, or mu k. Right? How will I find mu k? I'm having inclined plane. Like this. Okay. What are the forces acting on the block? Now, in case of kinetic friction, block or box will slip. So if my observer is standing here at point O, so we'll find that block is slipping downwards. Okay, because this is the angle of inclination theta is equal to 30 degree. It will slip downwards with acceleration a. So here a is what? Non-zero. That you have to remember. So when a is non-zero, we need to apply what? Newton's laws of motion. Second law. Right? So if we are applying Newton's second law, then in that case, the first force acting is mg. So this component will be what? This angle is theta. Since this angle is theta, so this will be mg cos theta. This will be mg sine theta, which is parallel to inclined plane. Okay. And this is mg sine theta. Now tell me what is the normal reaction? It will act perpendicular to the inclined plane. So it will act in this direction, N. Okay. And the third force will be frictional force, F, which will act opposite to the relative motion. Now, here in kinetic friction, there is no tendency of relative motion. Rather, there is actual relative motion of box. Okay, box is moving, box is slipping downwards. Box is slipping downwards. There is no tendency, but there is actual relative motion. Relative motion with respect to observer O. Okay, which is watching the process from point O. So here this, if I am taking force balances, force balance, if I am taking vertical equilibrium, this n will be what? N will be mg cos theta. This n will be equal to mg cos theta. And horizontal equilibrium, if I am writing the equation, since there will be motion, there is no motion in vertical direction, rather there is motion in horizontal direction. This vertical equilibrium is along inclined plane, and this horizontal equilibrium is also along inclined plane. Okay, so MA will be equal to what? MA will be equal to mg sin theta, this force mg sin theta minus F, since relative motion will be downwards along inclined plane, the friction will oppose the relative motion, it will act upward along inclined plane. Okay, so what is the value of F here? F is what? F is mu k into n. What is the value of n? Here F is what? Mu k into n in case of kinetic friction, which is constant. What is the value of n? N is mg cos theta. So this is minus mg cos theta into mu k is equal to ma. This is m gets cancelled. So this a is what? A is g, I am taking common, sin theta minus mu k g cos theta. Okay. Now, if you solve this problem, this g is can be taken as 10 meter per second square, and they are given some other information. The box starts to slip. Okay, the box starts to slip and slides 4 meter down the plank in 4 seconds. Right. So it means that this will slip by 4 meter in 4 seconds. So I need to, initial velocity is 0, right? Time required for covering displacement of 4 meter is 4 seconds, and displacement is what? 4 meters. So I am having S is equal to what? Ut plus half at square. This is 4, this is 0, U is 0. This T is what? 4. So this is 4 into 4 into A divided by 2. So this 4 gets cancelled. This becomes 2A. So 2A is equal to 1. So A is equal to 1 by 2 meter per second square. This is the acceleration with which block is slipping. Half meter per second square. Right. So here, if I am putting the values, half is equal to what? 10. Half is equal to 10 into, what is sine 30? 1 by 2 minus mu k into, what is this? G is not there, I have taken it outside. This mu k into cos theta. Cos theta is root 3 by 2. Right? So if I am taking 2 outside, I will be getting 10 into 1 minus root 3 mu k. Right? So this 2 gets cancelled. So this becomes 1 by 10 is equal to 1 minus root 3 mu k. So mu k is equal to root 3 mu k is equal to what? 1 minus 1 by 10. So this will be 9 by 10, which can be written like this: root 3 into root 3. Root 3 into root 3 is 3 into 3 divided by 10. So this root 3 gets cancelled. So I'll be having finally mu k is equal to 3 root 3 by 10. What is the value of root 3? It's 1.41 approximately divided by 10. So this is what? This is 5.1 by 10 approximately, which is nothing but 0.51, which is nothing but 0.5. So mu k will be 0.5. Okay. So here I'm having value of mu s as zero point 0.6, zero point 0.6, value of mu s as 0.6. Okay, and value of mu k as 0.5. So what is the right option? Option number D. So the right answer to question number 5 is D. So thank you very much, and I'll be posting the other video on tomorrow.